We want to continue working through the review, starting with number 4. In the 2004 baseball season, one of the Seattle Mariners set the record for the most hits in the season, with a total of 262 hits. In the following probability distribution, the random variable x represents the number of hits he obtained in a game. So maybe he only got 1 hit in a game, or 0 hits in a game, 2 hits, 3 hits. Of his 262 hits, these were the probabilities of him getting a certain hit. So part A wants us to compute and interpret the mean. So the first thing that we need to do is compute the mean. Remember that the mean for a probability distribution like this is going to be the value times its probability, and then we add each of those up. So we're going to take 0 times 0.1677 plus 1 times 0.3354 plus 2 times a 0.2857 plus 3 times a 0.1491 plus 4 times a 0.0373 plus 5 times a 0.0248. Okay. Recall that 0 times anything is 0. 1 times anything is itself. Don't put a parentheses there. Plus 2 times 0.2857 is going to be a 0.5714. 3 times a 0.1491 is going to be a 0.4473. 4 times a 0.0373 is going to be a 0.1492. And 5 times a 0.0248 is going to be a 0.124. We add this up and we get 1.6273. Then we need to interpret it. Whenever it's talking about interpret it, it means describe the mean in terms of the actual application. So we're talking about the number of hits that this person gets per game. So on average, Akiro, and I misspelled that. Let me correct that. We'll get 1.6273 hits per game. Now, I understand that he can only get 1 or he can get 2 hits. He can't get in between, but we're talking about an average. Think about quiz scores or exam scores or anything like that. You can get a 95 or you can get a 96, but on average, maybe you have a 95.4. Same situation applies here. Okay? So now then, what is the probability that in a randomly selected game, he got 2 hits? Well, 2 hits is just the 2, so we come up here and probability that he got 2 hits was 0.2857. So probability that the value is 2 is 0.2857. So the probability that in a randomly selected game, Akiro got 2 hits is 0.2857. Part C. What is the probability that in a randomly selected game, Akiro got more than 1 hit? More than 1. So if he just got 1, that doesn't count because we want more than 1. More than 1 is going to include 2, 3, 4, and 5. So we want the probability that he gets more than 1, which is going to be the probability that he gets 2.2857, plus the probability of 3, which is 0.1491, plus the probability of 4, 0.0373, plus the probability of 5, which is 0.0248. We're going to add those together, And when we do, we get 0.4969. So the probability that in a randomly selected game Akira got more than one hit is 0.4969. Okay, looking at problem 5. Paper toss is a popular application for smartphones. The goal of the game is to toss crumpled paper into a trash can while accounting for wind from a fan. The following data represents the ratings on a scale from 1 to 5, with 1 representing a poor rating. So in other words, these are the ratings that you would give 1 star, 2 star, 3 star, that type of thing. We have a 1, 2, 3, 4, and 5. The frequency is, there were 2,752 people that gave it a 1, 2,331 people that gave it a 2, and so forth. We don't have the probabilities. We actually just have the frequencies. So we first need to find out how many total people evaluated this game. So we add each of these up. When we add this up, we get that there were 23,718 people that evaluated or rated this game. So in order to get the probability is the exact same thing as relative frequency. When we talk about relative frequency, we talk about the value minus the total number of possibilities. So we talk about the frequency divided by the total. So for a rating of 1, we're going to take 2,752 divided by 23,718. And in that case, we get 0.116. For the probability for a rating of 2, we have 2,331 divided by 23,718, and we get a 0.098. And we're going to continue. So 4,215 divided by 23,718 is 0.178. 3,902 divided by 23,718 is 0.165. 10,518 divided by 23,718 is going to be a 0.443. In order for us to use a probability distribution, we got to know what our probabilities are first. Now we want to compute the mean and standard deviation for this information. So our mean is going to be the value, the 1, times its probability, plus the 2 times its probability, the 3 times its probability, the 4 times its probability, and the 5 times its probability. So 1 times 0.116 is 0.116. 2 times a 0.098 is going to be a 0.196. 3 times 0.178 is going to be a 0.534. 4 times a 0.165 is going to be a 0.66. And 5 times 0.443 is going to be a 2.215. We add all of this up and we get 3.721. So the mean is not 0. It is 3.721. Now again, I'm going to draw a line to divide this off so we can look at standard deviation. We have to first calculate the variance. So the variance is the value minus the mean, value minus the mean squared, and the value minus the mean squared times the probability of x. So our values are 1, 2, 3, 4, and 5. So 1 minus 3.721 is going to give me a negative 2.721. That value squared, recall that I want to put parentheses around that and then do the square so that I get a positive value here. So it's going to be 7.403841. And then I'm going to multiply that times its probability. So I would take this 7.403841 times the 0.116, and I get 0.8588. Now we're going to take the 2 minus the 3.721. I'm going to get a negative 1.721. We're going to square that. Negative times negative gives me a positive. It gives me a positive 2.961841. I'm going to take this value times its probability. Its probability was 0.098. And I get a 0.2903. We'll take 3 minus 3.721. Gives us a negative 0.721. Negative 0.721 squared is going to be 0.519841. This value is going to be multiplied by its probability of 0.178. So we get a 0.0925. 4 minus 3.721 is going to give me a positive 0.279. Positive 0.279 squared will give me a 0.077841. We're going to take that 0.077841 times its probability of 0.165, which will give me a 0.0128. 5 minus 3.721 will give me a 1.279. 1.279 squared will give me a 1.635841. We need to multiply this by its probability of 0.443, and we get a 0.7727. To find our variance, we add up all of these values. So it's the sum of the value minus the mean squared times the probability. So I'm going to take this last column and add it up. When I add up this column, I get 2.0271. That is my variance. I need to find the standard deviation, which means to take the square root of that value. So whenever I take the square root of that, I get 1.42376. So the standard deviation is a 1.42376. I want you to continue practicing, and then we will look at some other questions in the next video.